Now, what happens if you need to plot more than one graph in the same coordinate system? Well, you can just pick out the first graph, plot it, then pick out the second graph, plot it, and then you are done. Remember, we can plot graphs by calculating the x and the y intercepts and then just draw the line in between. But what happens if you end up with something like this, which is quite often common for the supply-demand analysis? So you've got your demand and you've got your supply. So there is a point here which we call the point of intersection. Point of intersection in mathematics, or you call it equilibrium in economics. What's important about this particular point is that this point satisfies both of the lines because it lies exactly on both of them. So this is an important point because this is where supply meets demand in a supply-demand analysis. However, this also can be calculated algebraically by solving systems of linear equations. And if you don't know how to do that, there is a very good website called the Khan Academy, which you can check out the different ways of solving systems of linear equations. Now, let's look at a somewhat different example when it comes to plotting more than one graphs. So QXD equals 5,000 minus 0.5px plus 0.25m plus 2py. Now draw the two demand curves given that m1 is equal to 2000 and m2 is equal to 3000 and py equals 5 for both cases. Now first I'm going to deal with the m1 equals 2000. To be able to find that demand function, what I need to do first, I need to substitute m1 and py into the original equation. So qxd will be equal to 5000 minus 0.5px plus 0.25 times m1, which is 2000, plus 2 times py, which is 5. So I can bring the numbers together and use the calculator to do the calculation quickly for me. So the first number is 5000. I have to add 0.25 times 2000 to it, plus the 2 times 5. So I ended up with having 5510 minus 0.5px, and that was the first case. That's the case of the m1. So how am I going to do m2? M2 will be a very similar case. All I need to do now is pick up the original equation and now substitute m for 3000 instead of 2000. So the QXD will be 5000 minus 0.5px plus 0.25 times m is now 3000 instead of 2000, but py hasn't changed because it says that py is 5 in both cases. So I can again pick up the calculator and calculate all the numbers. And that altogether will give me 5760 minus 0.5px. So that is the equation for the second. So this is the second when m is 3000, and this is the first when m is 2000. Now I need to draw these two graphs. So I'm going to do that on the next page. Now, how can I draw a linear graph? Well, I can draw the two intercepts. So if I choose Px to be 0, what would be the Q coordinate? Well, if Px is 0, then this part disappears because 0 times anything is always 0, so that's easy. So Qx then will be 5, 5, 10. But what happens if I choose Qx to be 0? Well, that would make the equation 0 equal 5, 5, 10 minus 0.5 Px, and now I have to solve it. So what I need to do, I need to move the negative to the other side. So I would have positive 0.5 Px being equal to 5, 5, 10. And now I need to divide by 0.5 both cases. That cancels down to 1. So Px will be 5,510 divided by a half gives me 11020. So if Q is 0, then Px is 11020. For the second line, similarly, if I choose Px to be 0, then Qx easily can be read off just by ignoring this part, which now is 0, 5760. But if I choose Qx to be 0, I again have to do a calculation. So 0 equals 5760 minus 0.5 Px. Exactly the same way as before, I'm going to move the 0.5p over to this side to make it positive. And now I'm gonna need to divide by that 0.5 down to have Px on its own. So 5760 divided by 0.5 gives you 11520. Now I need to draw these two lines. Remember, this is P and this is Q. Now, in P, I need to go up to 11,520, so I need to go up quite high. But in Q, I'm only going up to 5,500 or 5,760. So Q, I don't need to go up into such heights. So what I can do in Q, I can choose this to be 1,000, same distance to be 2,000, 3,000, 4,000, 5,000, 6,000. Okay? But in P, if I go up in thousands, that's not going to be enough because I've got smaller space in here. So maybe if I go up in 2,000, that could be good. So 2, 4, 6, 8, 10, 12. That's still quite a bit tight. So let's go up in 4,000s. And then it gives me 12,000. Now, as you can see, my scale are not detailed enough. So all I can do now is do a sketch, a rough guessing where these points would be. So for the blue graph, I need P to be 0 and Q to be 5,510. Now that would be somewhere, this is 5,500, exactly halfway in between the two, so I can put that more or less there. So that would be the 0, 5, 5, 10 point. And then for Q to be 0, P needs to be 11,020. Well, halfway between would be the 10,000. A halfway between here would be the 11,000, so that would be somewhere there. So the first line is something like that. Let's see how does it change for the green line. For the green line, when P is 0, Q is 5,760. Remember, this was 5,500, so 5,750 would be somewhere halfway between, so it's just a little bit before. Okay, and then this green would be the 0, 5,760. Again, my scale isn't detailed enough to find the exact point, so I need to be a little bit careful in here. And then the P would be 11,520. Well, that's about 500 above, so that would be somewhere around here. It's very, very close to 12,000, because this scale, don't forget, it goes 4,000 up. So this tiny little distance can easily be 500. And then draw the graph. And if I was to use rulers, and if I was to use a bigger paper, it would show you quite nicely that the two lines are actually parallel. So what happened here? Well, just by increasing my budget, which was M, from 2,000 to 3,000, remember that was the difference between the blue and the green. What happened, I was able to push up my budget line a little bit higher up. So now I can afford different combinations that I was not able to afford with the blue line. So I've got an extra money to spend.